In this example, we're asked to find a polynomial function of degree 3 that has zeros of 4 and 2 plus 3i. We are told that this is degree 3. Remember when we discussed in class the Fundamental Theorem of Algebra that told us if we have a polynomial function of degree 3 that tells us that the real zeros in this example plus the complex zeros will equal the degree. So when we add the total number of real zeros to the total number of complex zeros, we should get 3. Now notice I only gave you 4 and 2 plus 3i as our zeros. What that means is that there's one missing. And as we saw in class, we know that complex zeros come in pairs. So if we know that our zeros, right, and this is what I like to do, I like to write the zeros. Therefore, it's 2 plus 3i. And if we know 2 plus 3i is a 0, we automatically know its conjugate is also included. So that's 2 minus 3i. Right? So we know that 4, 2 plus 3i, and 2 minus 3i, the conjugate of the complex 0, is also a 0. What does that tell us? Well, remember, if we know that these things are factors, or excuse me, these are zeros, we can find the factors associated with these zeros. If 4 is a 0, then we know x minus 4, x minus the 0, x minus 4, and I'm going to put it in parentheses for a reason. It's just x minus 4. Right? This is a factor. This was kind of part of our factor theorem. If we know 4 is a 0, then when we plug that into a completely factored polynomial, we better get 0. In other words, if we plug in 4, then this part right here, this factor, will equal 0, which will cancel out all the other factors. Doesn't matter what they are. If we completely factor a polynomial and 4 is a 0, then it'll cause this factor to be 0, causing the entire string of multiplication to be 0. We also know that if 2 plus 3i following the same pattern, then we know that x minus this quantity, it's always x minus the 0, will also be a 0. Or excuse me, I'm messing these words up. If 2 plus 3i is a 0, then we know x minus this entire value will be a factor. Right? So this will be, when you simplify this, x minus 2 minus 3i. And I got that just by distributing this subtraction sign. I'm subtracting this entire quantity. And finally, if I have a 0 of 2 minus 3i, then the quantity x minus this whole thing, x minus the quantity 2 minus 3i, will also be a factor. And when you simplify this, you will get x minus 2 plus 3i. The reason it's plus, again, because we have to subtract this whole quantity, we're subtracting both terms. When we subtract a negative 3i, that becomes a positive 3i. So here are our factors associated with this polynomial. If we have zeros of 4, 2 plus 3i, and 2 minus 3i, then our polynomial can be factored into these 3 factors. So what we're going to have to do, and I'm going to actually do this on the next page so I have enough room, is if we know these are factors, then I'm going to be multiplying this out, this entire quantity. Now there's lots of ways that we can do this. There are tricks working with the difference of squares. But what I'm going to do is I'm just going to multiply this pretty straightforward using a graphic organizer method. Multiplying a polynomial times a polynomial. The only trick is to just be careful when we are multiplying I times I, and we're going to have different i's involved here. Now another rule of thumb that we're going to see is that when you're multiplying a lot of factors, you don't want to try to distribute this x to this x and then this one. You want to just choose 2 factors and multiply them. Get their product, and then on the next step, then multiply that by the remaining factor. You don't want to try too much at once. So what I'm going to do on the next page here, I'm going to take this entire polynomial and I'm going to multiply it out. But the first thing I'm going to do is I'm going to multiply these two complex factors, and then whatever I get there, I'll multiply x minus 4 times that product. What we'll find is that there's going to be a lot of things that cancel when we multiply these two factors. On this slide, I'm going to multiply the factor x minus 2 minus 3i times the factor x minus 2 plus 3i, and I'm going to use this graphic organizer here on the left to multiply this out. Now, if you're unfamiliar with this, I would suggest looking up a previous podcast I can link to right here, and this illustrates how we can multiply polynomials using a graphic organizer or a box, what I call the box method. Now, once we write the terms, which is a trinomial because we have three terms. I guess it's not technically a trinomial, but we do have three terms that we're multiplying, so we're going to write that down on the left side. And we have three terms up above that I will write. And now what I'm going to do is I'm going to find the area of each little box. So I'm going to fill this in. This should be a little bit of a review. So x squared minus 2x. And this is going to be positive 3xi. And now I'm going to multiply negative 2 times all these terms up top. I'll have negative 2x, 4, and negative 6i. And then here I will have a minus 3xi. I will have a positive 6i because this is a negative times a negative, so that's positive. And then finally I will have a minus 9i squared, which will turn into a positive 9. Because I squared is equal to negative 1. Negative 1 times negative 9 will equal a positive 9. Now what I'm going to do now is add all of these boxes together. But before I do that, I'm going to cross off the ones that I know are going to cancel. I know some things are going to cancel. And I see here that it looks like this 6i and minus 6i will cancel, but also the minus 3xi and the positive 3xi. This is always going to happen. This will happen when you multiply these things out. So what we find is that when we multiply these two factors here, we will get what's in the remaining boxes here. So we're going to have x squared. Right? We're also going to now, so I just added that up, so I'll cross that off. And now it looks like we have a minus 2x and another minus 2x, so that's a total of minus 4x. So I will cross off that I subtracted those. And when I add this box of 4 and add this box of 9, I will get 13. So that's positive 13. Okay. So when I multiplied these two factors, I got this trinomial, x squared minus 4x plus 13. But don't forget that x plus 4 is still a factor of this polynomial that's still out front. So what I'm going to try to do now is I'm going to FOIL this out. I'm going to multiply this out, and you could once again now use the box method, use the same kind of graphic organizer to set this up, right? But I'm going to see if I can move this over a little bit. I guess we don't need that anymore, just so I can kind of create some room here. What I'm going to do now is I'm going to multiply these two. So I guess I will do the box method again. X minus 4, and we're going to have x squared minus 4x, and maybe I'll just add one more column there. We'll have 13. So now, when I find the area of each one of these boxes, we'll have x to the third minus 4x squared. This will be 13x minus 4x squared. This will be a minus 16x, and minus 4 times 13 is a negative 52. So I'm going to write this out here so I have space. Negative 52. Now let's put these together. So I'll have x to the third. I have how many x squareds? Well, here's a minus 4. Right? Here's a minus 4. When they cancel out, there'll be a minus. They're not going to cancel. It'll be a minus 8x squareds. And then I will combine the minus 16x with the positive 13x. That is a minus 3x. And then finally a minus 52. What I just found when I multiplied this function entirely out, I get a function x squared minus 8x minus 3x minus 52. This function has zeros of 4, 2 plus 3i, but also 2 minus 3i. Right? I got this by knowing what the zeros are, knowing that a complex zero will have its conjugate also be a zero. I find the factors by taking x minus each one of the zeros, and then I multiply that out entirely to get this function, x to the third minus 8x squared minus 3x minus 52. I'd like to make a quick correction. I see now, once I stopped filming and went back, that I made a mistake. This would not be a minus 3x. The reason why, this term right here, right? This box should be a plus 16x, and I'm going to combine that with this plus 13x, so that will be a total of 29 x's. Right? So that's what it should be. Right? I'm going to take this and write this. Let me just scoot some of this stuff over, not to make things more complicated, but I can scoot some of all this over here. We're going to have our function be x to the third minus 8x squared plus 29x minus 52. Right? So I have that function that I had originally here, but instead of having that minus 3x, it's now plus 29x. And the reason why, I made a tiny mistake when I multiplied minus 4 times minus 4x. It should be a positive 16x.